Hello, my name is Maddie, and today I'll be talking about our work on human-inspired robot with manipulation. Preparatory actions increase range and reduce control effort. When it comes to robots manipulating flexible objects, here's a video from 2017 that shows a robot manipulating a rope on a plane, and you can see that the video has to be sped up 20 times to make it appear in real time. If we fast forward to 2023 and 2025, while the algorithms and techniques used to train and program these robots have improved vastly, we still see that videos have to be sped up many times to make them appear in real time. This is in contrast to humans manipulating such objects, where we actually have to slow down the videos to truly appreciate the skill that goes into manipulating them. And in our lab, we specifically study how humans manipulate whips to hit targets. And our goal is to learn from humans manipulating such objects and developing better algorithms and controls for robots to do the same. And so we simplified the whip manipulation task to a 3D printed whip that can only move in planar motion. And we asked participants to manipulate this whip, and we simply observed the strategies they used to do the task. In our experiments, we saw two dominant strategies arise. One is striking only, where the participant makes a single forward motion to strike the target. And the other one, which is preparing and striking, where the participant makes this extra backward motion to prepare the whip to hit the target. So we want to understand the benefits of this extra preparatory movement. So we designed a minimum jerk trajectory controller that can design trajectories to mimic these two strategies of humans. And here you can see in simulation the striking only and the preparing and striking strategies that were developed using that minimum jerk trajectory plan. Now what we can do is we can do a grid search of different target locations and design optimal trajectories to try to get the whip to hit the target with these two strategies. In the bottom left, you see the target locations that were successfully hit with the striking only strategy. And if we do the same search with the preparing and striking, we can see that with this additional preparation, it allows for farther targets to be hit with the whip. And the other thing we looked for was control effort. And here you can see the control effort for the two strategies to hit the different targets. And you can see, especially for targets farther away, the control effort needed to do the task is lower for the preparing and striking strategy. And so overall, the additional preparatory movement, lower control effort is needed to hit targets, and more targets can be reached. Lastly, we implement this trajectory on a physical Franka robot arm to show that a real robot can also use these techniques to hit a target. In conclusion, we developed a human-inspired control framework to manipulate a whip to hit a target. And from human observations, we showed two control strategies to do this task. And we showed that by having an extra preparatory movement, you can reduce the control effort needed to do the task and reach farther targets. And the key takeaway is that object preparation is an important yet understudied aspect of robot manipulation of complex underactuated objects. With that, I'd like to acknowledge my collaborators and thank our funding sources, and thank you for your time.